Okay, here we are, Algebra 1, Introduction to Systems of Equations, Guided Notes. For the warm-up, you're testing to see whether a point is a solution to an equation. In order to do so, you're going to put the x value of 4 in place of x into the equation, and the y value of 5 in place of y into the equation, and test whether it's true. When you're done, give B a try. So pause this video and come back on when you're ready. Okay. Here we go. 3 times 4 is 12, plus 2 times 5 is 10. Does that equal 8? And the answer is no. It does not equal 8. So therefore, 4, 5 is not a solution. Okay, and part B, if I put in -1 in for x and 3 in for y, I have 3 equals 3 times -1 plus 6. 3 times -1 is -3 plus 6 is 3. And since 3 does equal 3, we would say, yes, -1, 3 is a solution to this equation. What we're going to be doing in this next unit is taking a look at something called system of equations. And a system of equations are two or more equations, okay, we're going to be working together at the same time. Okay, so two or more equations working together. And a solution to a system of equations is the ordered pair that makes both equations true. Okay, so essentially it's the ordered pair that works in both equations. So if you want to test to see if an ordered pair is a solution to a system of equations, you have to put that point into both equations. So this is an example of a system of equations. And if I wanted to test the point 1, 5, I would have to put 1 in for x and 5 in for y into both equations. So I would have 5 times 1 minus 2 times 5 and test to see if that equals 5. 5 times 1 is 5, minus 2 times 5 is 10. 5 minus 10 is equal to -5, so it does check out. I also need to make sure it works in the other equation as well, so I'm still going to put 1 in for x and 5 in for y. 3 times 1 is 3, minus 7 times 5 is 35, and I'm questioning whether that equals -32. 3 minus 35 is -32, so it checks out as well. So therefore, 1, 5 is a solution because it is true for both equations. Now if you check the point 2, 4, is that a solution to the system of equations? We would put 2 in for x, 4 in for y, and test it out. In this case, you've got to be careful because the y's and x's are reversed. So 3 times y, so 3 times 4, minus 2 times 2, because x is 2, is that equal to -2? Well, 3 times 4 is 12, and 2 times 2 is 4. Is 12 minus 4 equal to -2? No, it's not. So therefore, I don't even have to go any further. If you wanted to, you could check the other equation. You would find that 4 plus 2 times 2, which is 4, is equal to 8. So it does check out in the second equation, but it's not a solution for the system of equations because it does not make both equations true. So no, because it is not true for both equations. All right, so let's take a look at the next page, page 2 of your packet. So this is just some practice here on the top of page 2. Tell whether the ordered pair is a solution to the system of equations and show your work. So what you're going to do for each of these problems is you're going to substitute a value in for x and a value in for y from the given ordered pair and test to see if it makes the equation true. You want to make sure you're careful when you're substituting in a negative value to watch your signs with your operations, and if whenever in doubt, if you want to substitute in parentheses, it'll help keep you from making mistakes. Let's move on down to methods for solving systems of equations. You may remember from 8th grade, you guys learned 3 ways to solve systems of equations. One was by using graphing, and we looked for where the lines had an intersection or points in common. We also learned a method called substitution. And the last method, Carnegie calls linear combination, but another word they use for this is elimination. So you'll see it called both ways, elimination. When you solve the systems of equations, you have 3 outcomes that are possible. All right. You could end up with an independent system, and an independent system is when there is only one solution. This is also consistent. Consistent just means that there is a solution. Dependent system means that there is an infinite number of solutions. And inconsistent system means that there are no solutions. And we're going to revisit this in a couple minutes when we look at the graphs. So let's take a look at page 3. Just a little practice with graphing at the top of page 3. When we're graphing from slope-intercept form, the best thing to do is identify the slope. In this case is 1/2. It's the coefficient of the x. So that's your rise over run. And your y-intercept is -3. So the first step is to start at the y-intercept and go down to -3 and put that point there. The second step is to use rise over run to establish some more points on your line. A slope of 1/2 means rise 1 and run 2. So up 1 and right 2, up 1, right 2, up 1, right 2, and so on. Okay, once you get a few points, sometimes it's good to get a bunch to make sure your line is accurate. Now, number 2 is in standard form. Standard form is a little different, and you have a couple options. You could also have used your graphing calculator for number 1, but you could not have used your graphing calculator for number 2 because it's not in slope-intercept form. So one method would be to rewrite this in slope-intercept form, and to do that you would just subtract 8x from both sides. You would have 4y equals -8x plus 16, and then you would divide every single term by 4, and you have y equals -2x plus 4. Another method when you have an equation in standard form is just to make a quick little table of values. And 2 easy points to get are your x and y intercepts. I know the x-intercept is when y is 0. So if I substitute 0 in for y into the equation, I would have 8x plus 4 times 0 equals 16. Well, anything times 0 is 0, and anything plus 0 is itself. So you really just have 8x equals 16, and 8 times 2 is 16. So therefore my x-intercept is 2. If I want to find my y-intercept, I would put 0 in for x and do a similar idea. So I would have 8 times 0 plus 4y equals 16. Well, anything times 0 is 0, anything plus 0 is itself. So that's why some people call this the cover-up method. When you want to find the y-intercept, just cover up the x term and solve for y. When you want to find the x-intercept, cover up the y term and solve for x. So 4 times what is 16? 4 times 4 is 16. So the y-intercept is 4. Plot these 2 points, 2, 0, and 0, 4. 1, 2, 3. And you've got yourself an equation, a line, a graph. The next part down below is just seeing if you can state the ordered pair that is an intersection. Just getting practice ready for when you're going to be solving a system of equations by graphing, because that's the method we're going to practice today. Basically, you're just going to put 2 graphs on the same coordinate plane, and you're going to be looking for the intersection of 2 lines. So this activity is just getting you used to practicing. So if you were to state the intersection of lines A and line B, you would look for line A is right here, and line B is right here. So I'm basically looking for you to tell me the name of the point where they intersect. What is the ordered pair right there? Well, starting from the origin, I have to travel left 3 and up 1, 2, 3, 4, 5, 6. So the ordered pair would be negative 3, 6. I'll let you finish the rest of those for practice. So let's move on down to the bottom of the page. And this is going to be the steps you're going to take when you're solving systems of equations by graphing. Step 1 is you are going to graph both lines. Okay, what you're going to look for is the intersection. Okay, and when you're all done, you can check your answer by substituting the point you found, the ordered pair, into both equations. All right, and check that it makes both true. All right, let's practice a couple of these. All right, so if I looked at number 1 on the top of page 3, page 4, I'm going to graph both equations. So number 1, you'll notice there's no y-intercept, which means it's 0. So I'm going to graph the top equation by putting my y-intercept on 0, and my slope is 1 over 3. So I'm going up 1 and right 3. Up 1, right 3. You also can go down 1 and left 3. Okay, when all said and done, if your slope is positive, you want to make sure as you read your graph left to right that your graph is increasing. So this is the graph of y equals 1/3 x. Now I'm going to graph y equals negative 2x minus 7. In order to do that, you want to make sure you start by plotting the y-intercept, negative 7. And then from there, the slope is negative 2. When the slope is a whole number, you can think of it as negative 2 over 1, which means you can go down 2 and right 1, or you can go up 2 and left 1. But when you step back and look at your graph, you want to make sure that you can see that your graph is decreasing as you read the graph left to right. So my job right now is to take a look. The solution to the system of equation is the intersection of the 2 lines, and it's the name of the ordered pair. So that is my solution. All right, and my solution would be negative 3 comma negative 1, because from the origin I went left 3 and down 1. Now there's a couple different cases you'll find when you're graphing. Case 1 would be when you actually have the intersection of 2 lines, you end up with one solution. Sometimes you can come across a situation where you actually have 2 of the same equations. Usually one of them will be in disguise, but they actually end up being the same equation and actually graph, imagine 2 lines graphed on top of each other. That's going to be when there's an infinite number of solutions. And once in a while you'll come across a situation where you have 2 parallel lines, basically have the same slope but different y-intercepts, in which case there's no intersection of the lines, so there would be no solutions. So hopefully this gave you a good idea. Please complete the work in the rest of this packet and rewatch this video as needed. All right, good luck, and I'll see you guys next week.